Lesson: Future Directions in Ethical AI and Cybersecurity. The integration of artificial intelligence in cybersecurity has ushered in a new era of technological advancement and has significantly augmented the capabilities of security systems. However, this rapid progression necessitates a critical examination of ethical considerations and future directions to ensure that AI's deployment not only enhances cybersecurity, but also aligns with ethical norms and legal frameworks. Ethical AI and cybersecurity must address issues such as bias, transparency, accountability, and the protection of privacy, which are paramount to fostering trust and security in digital ecosystems. AI systems are inherently complex and often function as opaque black boxes, where even developers might have limited understanding of how specific decisions are made. This opacity poses substantial ethical dilemmas, particularly concerning transparency. For instance, if an AI system flags certain behaviors as suspicious, it is crucial to understand the rationale behind such decisions to avoid unjust implications or actions against individuals or entities. The lack of transparency can lead to mistrust among users and stakeholders and may inadvertently perpetuate biases present in the training data. Ensuring transparency in AI systems involves developing explainable AI, which aims to make AI decision-making processes more interpretable and understandable to humans. Techniques like model distillation, saliency mapping, and local interpretable model-agnostic explanations are being explored to enhance transparency and accountability in AI-driven cybersecurity applications. Bias in AI systems is another critical ethical concern. AI models trained on biased datasets can reinforce and amplify existing prejudices, potentially leading to discriminatory practices. For example, if a cybersecurity AI system is trained on data that overrepresents certain demographics as potential threats, it may disproportionately target individuals from those demographics, leading to unfair treatment and potential violations of human rights. Addressing bias requires a multifaceted approach, including the careful curation of training datasets, continuous monitoring for biased outputs, and the implementation of fairness-aware algorithms that actively mitigate bias. Researchers are also investigating fairness-enhancing interventions, such as reweighting data samples or incorporating fairness constraints into the learning process to ensure that AI systems behave equitably across different user groups. The ethical deployment of AI in cybersecurity also necessitates robust accountability mechanisms. When AI systems make autonomous decisions that lead to adverse outcomes, determining responsibility can be challenging. Traditional legal frameworks may not adequately address the complexities introduced by AI, leading to potential gaps in accountability. There is a growing consensus that AI systems should be designed with built-in accountability features, such as detailed logging of decision-making processes and clear documentation of system behavior under various conditions. This not only aids in auditing and compliance efforts, but also ensures that stakeholders can trace and understand the sequence of events leading to specific outcomes. Additionally, there is a need for legal and regulatory frameworks that define clear guidelines for AI accountability, ensuring that developers, operators, and users of AI systems are held to appropriate standards of responsibility. Privacy protection remains a cornerstone of ethical AI and cybersecurity. The deployment of AI in cybersecurity often involves the collection and analysis of vast amounts of data, raising concerns about user privacy and data security. Ensuring that AI-driven cybersecurity solutions adhere to stringent privacy standards is essential to maintaining user trust and safeguarding sensitive information. Techniques such as differential privacy, which adds statistical noise to datasets to prevent the re-identification of individuals, and federated learning, which allows AI models to be trained on decentralized data sources without sharing raw data, are being explored to enhance privacy in AI applications. Moreover, compliance with legal frameworks such as the General Data Protection Regulation and the California Consumer Privacy Act is crucial to ensure that AI-driven cybersecurity practices align with established privacy norms and regulations. In addition to these core ethical considerations, future directions in ethical AI and cybersecurity must also address the broader societal impacts of AI deployment. The rise of AI has the potential to reshape the labor market, with significant implications for employment in the cybersecurity sector. While AI can automate routine tasks and enhance efficiency, it may also displace certain job roles, necessitating a proactive approach to workforce development and retraining. Ensuring that workers are equipped with the skills required to thrive in an AI-enhanced cybersecurity landscape is crucial to mitigating the potential negative impacts of AI on employment. Moreover, the global nature of cybersecurity challenges necessitates international collaboration and the development of harmonized ethical standards for AI deployment. Cyber threats do not respect national boundaries, and a fragmented approach to AI ethics and cybersecurity can lead to vulnerabilities that are exploited by malicious actors. International organizations, such as the United Nations and the European Union, are increasingly recognizing the need for coordinated efforts to establish global ethical guidelines and best practices for AI in cybersecurity. These efforts aim to foster a collaborative environment where countries can share knowledge, resources, and strategies to address common cybersecurity challenges while upholding ethical principles. The integration of AI into cybersecurity also presents unique opportunities for enhancing security measures through innovative approaches. For example, AI-driven threat intelligence platforms can analyze vast amounts of data to identify emerging threats and predict potential cyber attacks with unprecedented accuracy. Machine learning algorithms can detect patterns and anomalies that may indicate malicious activity, enabling faster and more effective responses to cyber threats. However, the deployment of such advanced AI systems must be guided by ethical principles to ensure that they are used responsibly and do not infringe on individual rights or privacy. In conclusion, the future directions in ethical AI and cybersecurity encompass a multifaceted approach that addresses transparency, bias, accountability, privacy, and the broader societal impacts of AI deployment. Ensuring that AI systems are transparent and explainable is essential to building trust and understanding among users and stakeholders. Addressing bias and promoting fairness in AI models is crucial to preventing discriminatory practices and ensuring equitable treatment. Robust accountability mechanisms and clear legal frameworks are necessary to determine responsibility and ensure compliance with ethical standards. Protecting privacy through advanced techniques and adhering to legal regulations is fundamental to maintaining user trust and safeguarding sensitive information. Additionally, proactive workforce development and international collaboration are essential to harness the potential of AI while mitigating its potential negative impacts on employment and global cybersecurity. By adhering to these ethical principles, the deployment of AI in cybersecurity can enhance security measures while upholding the values of fairness, transparency, and accountability.